Okay, so here's a question that is talking about triangles. It's talking about a perpendicular bisector. That means that that must be the same length as that, because it's cutting it in half, because it was an equilateral triangle. And BX is an angle bisector of angle ABC. And we've got to show that these two triangles are similar. So they're asking us to work with triangle BXD. So BXD. And they're then asking us to work with triangle ACD. Well, with picture questions, always recommend, before you start thinking about the question itself, add onto the picture all the information you know. So we know this is about an equilateral triangle, so therefore straight away we can put 60 degrees there, 60 degrees for the whole of that. And this we would be putting 60 degrees for the whole of it, but they have told us that BX is an angle bisector. So key information, angle bisector, telling us it cuts the angle in half. So that is 30 degrees and that is 30 degrees. Now again, because we know things about triangles, angles add up to 180 degrees, we can now go through, that must be 90 degrees because angles of a straight line meet and add up to 180. That then, because angles in a triangle add up to 180, must be 60 degrees. And because that's 60 and 90, this angle here must be 30 degrees. So we've gone through and we've added on lots of information just from knowing that the fact that it was an equilateral triangle and the angle was bisected. We're trying to show that these two triangles are similar. So if we draw them both out in the same orientation, then we've got A, D, C. Put the information in that we know about it. That's 30 degrees, that's 60 degrees. Then if we draw out the other triangle, again, don't have to draw it accurately, it's just a sketch to give a feel for what's going on. So this triangle had D, B and X. And we know the angle there was 30 degrees, and we know the angle here was 60 degrees. So the angle at X was 60 degrees. When we compare these two triangles, we can see that actually all the angles in corresponding positions are identical, and that is the condition for similar triangles. So basically we would say here that all the angles in both triangles are in corresponding positions and equal. Therefore, triangles BXD and ACD are similar. So we've got this idea that similar triangles are when two triangles have all the corresponding angles identical, and one is literally just an enlargement of the other one. So all the angles in both triangles shouldn't really have the word "are" there. Doesn't really kind of make sense as good literature, good English. So all the angles in both triangles in corresponding positions. Don't need the word "and" there. Should be the word "are" there. So all the angles in both triangles in corresponding positions are equal. Therefore, triangles BXD and XD are similar. Okay, so that shows why the two triangles are similar. Then the question goes on and asks you to use the fact that AC is 2 centimetres. So again, we can start adding on information. If AC is 2 centimetres, then that means that the whole of this is 2 and the whole of this is 2. But they told us that the line AD is a perpendicular bisector to this, which means it's a line of symmetry on an equilateral triangle. So therefore the length of DC is 1. So DC has got a length of 1. And the length of DB has got a length of 1. We also know that AC has got a length of 2. And because of Pythagoras, again, when you've got a picture, add on things that you know. So because of Pythagoras, we can work out the length of AD. So AD equals, well, AD squared, because it's about Pythagoras. So AD squared is equal to AC squared subtract DC squared. long side takes short side to get the other short side. So AC squared is 4, 2 squared is 4, DC squared is 1. So AD squared equals 3. So AD is the square root of 3. So we do the opposite of squaring to get the answer for AD, so we square root 3. So we now know that AD is the root of 3. Well, one of the properties of similar shapes is that the ratio of corresponding sides has to also be the same. So we can see here that we've got a ratio of the root of 3 to 1. So I call that the scale factor, but lots of different ways of thinking about it. So the scale factor is the root of 3 over 1. So the root of 3. So basically, to turn any length on the small triangle into any length on the large triangle, we multiply every length by the root of 3. Now the question wants you to show that xd, it wants you to show that xd is equal to 1 over the root of 3. Well, when we look at the pictures to help us see what's going on, we can see that to go from the small triangle to the big triangle, we multiply all lengths by the scale factor of the root of 3. So coming the other way, from the large shape down to the small shape, we're going to divide by the scale factor. So we can say that xd is equal to dc over the scale factor. Well, dc had a length of 1, and therefore we've shown that xd is equal to 1 over the root of 3. So xd was dc over the root of 3, using the scale factor in reverse, and dc had a length of 1, so 1 over the root of 3. So that's shown that xd is what it needed to be.